So first of all, what is the first step to find out the location of poles by using this RH criterion or Roth-Harwich criterion is we supposed to examine the carry equation. So first of all, for examining the carry equation, the necessary condition for stability is nothing but that first condition is nothing but what, whatever the carry equation is there, the coefficients of that polynomial be positive. All the coefficients of the polynomial must be positive. That is the first condition it has to satisfy. If anything negative is there, then the coefficients of the carry equation is negative is there, then what happens, that all the, it will be unstable system. Directly we can say the first step is for finding out the stability, all the coefficients of the polynomial must be positive. If some of the coefficients are 0 or negative, it concluded to be the system is unstable system, not a stable system. Now that is the first job completed. We came to know that all the coefficients of this particular polynomial is positive. So when what we doing, the necessary, that is the first necessary condition. Even though if the coefficient, if the coefficients are positive, some of the roots may lie on the right half of a s plane or on the imaginary axis. So in order for all the roots to be negative real parts, it is necessarily but not sufficient that all coefficients of the carry equation be positive. So if all the coefficients of the carry equation are positive, then the system may be stable, it may be stable, and one should process the further to examine the sufficient conditions for the stability. Just you will get confused by reading all those things. Simply see here, even though if some of the coefficients are positive, uh, we can't say that the system is stable system. It's coefficients of the coefficient, that is the first necessary condition for continuing for the for going for the further examination. The first condition it has to be satisfied is that all the coefficients supposed to be positive. If any coefficients are negative, means what happens, the system will be unstable. We are not going for the further conditions, for the further examinations we are not going. So now we came to know that all the coefficients are positive. So one step got completed, one step is got cleared, so we supposed to go for the further examination. So now here, that are the that is the main condition we supposed to follow in the case of a RH criterion. So now here, how come we supposed to construct this criterion, RH criterion here is, so uh, the criterion is particularly based on ordering the coefficients of the carry equation into a schedule called that Roth array. So particularly, whatever this Harvard's criterion is there, it is particularly based on what, ordering the coefficients of the carry equation into a schedule. Is it clear? Into this particular schedule, it is clearly visible on the screen. Into a particular schedule, which we are calling it as a Roth array. Is it clear? So here what I am taking is, I am taking the nth order polynomial equation I have taken here. So this is the nth order carry equation I have taken, where a naught is greater than 0. So now what I'm doing is I'm just constructing the Roth array. So how the Roth array is constructed here, see here, one second, just I will let the other students in, one second, yeah, fine. So how we are going to construct Roth array, see, so here the power, here the s power maximum power is s power n what we are having. So first of all I'm starting with the s power n. So what here, if n is even, means the first row will be even coefficients we supposed to take. If n is odd number, the first row what here we are having is odd number coefficients we supposed to take. Is it clear? If n equals to 4 are having, so for example what I'm doing is, here I'm having n equals to 4. So what I supposed to take here, uh, s one is the coefficients of s power 4 I supposed to take, and s power 3 I should not take. The coefficient of s power 3 I should not take, and next x power 2 coefficient I supposed to take. Like that I supposed to take the first row, and second row, this s power n is the first row, second row is s power n minus 1. So now these coefficients I supposed to take, a1 for first s power n, a0, a2. This is just I am assuming that it is a odd, we are having n is odd number. So a0, a2, a4, a6, a8, like that I supposed to take. and second row what I supposed to take s power n minus 1 here a1 a3 a5 a7 a9 and so on, so like that it will be continued. So this first two rows whatever here we are having, that we directly get from this carry equation what we have here. Is it clear? With the help of this carry equation we can easily write this first two rows, first two rows it will be easily available for us. Now from this third row onwards we supposed to construct the array by doing the simple mathematical analysis. We supposed to construct this third row. From third row onwards we supposed to construct. Now for constructing this s power n minus 2, what I supposed to do, the elements of this s power n minus 2 here what we are having is b0 b1 b2 b3 b4. Is it clear? So how to find out this b0, just I will explain you. Now this fourth row what we are having is s power n minus 3 is the fourth row. So here this c0 c1 c2 c3 c4 are the elements of the fourth row. Now how come we are going to construct this third row? Now we'll discuss. Now we know that our main job is to, our main job is to find out this b naught. So for finding out this b naught, simply I will say that. So see here, the same here I'm just so like that what we're doing, we are just keep on constructing this. Finally up to what we supposed to construct the array, up to s power 0 we supposed to construct the array. So now after constructing the array, how come we can find out the system is stable? How come we can find out how many number of poles are located on a right of a s plane, how many poles are located on a left of a s plane, how many poles are located on an imaginary axis? So how come we can come to know means, see, first of all, the necessary and sufficient condition for stability is that nothing but what, all the systems of the first column of the row array is supposed to be uh, positive. See, with the help of this carry equation what I did, I have constructed the row array. Is it clear? This is a row array. If I having a n number of nth order means n number of rows I will get, right? Is it clear? So n number of rows I will got, and this is the array which I have constructed. Now how come I can find out the system is stable or unstable system? See, I supposed to examine this first row, first column elements. So if the first column elements are positive, there is no any negative sign here, so I say that the system is stable system. Is it clear? If the condition is met, if the condition is not met, then I say that the system is unstable system. Here there is no any negative sign over here. Is it clear? There is no any negative sign here. All the elements here in the first column we having a positive sign, no negative sign. So I said that the system is stable system. For example, now this is the row number 4. The element c0 which I having here is minus c0 having. Is it clear? So what we can say here, one of the element in this row in this first column is having a sign change here, positive to negative. This is positive, this is negative, and again negative to positive. There is a sign change here. So the condition not met, the condition the condition has to met. So the necessary and sufficient condition for stability is nothing but what, all the elements in the first column of the row array must be positive. Is it clear? But the thing what happens here, having a negative sign, I'm getting a negative sign here in the row number 4, in the row number 4 of the first column. So what I can say here, the system is stable system. So okay, I got a clarity that the system is stable system. Why? Because I have found one negative sign over here. Now one more thing here, what I supposed to do here, having a fourth order system means 4 rows I will get, right? So one sign change is there, one negative element is there. So how many sign changes here we are having? See here, for example, for this, positive to negative is one sign change, and again negative to positive another sign change. So two sign changes here we are having, two sign changes here we are having. Is it clear? If two sign changes means what, two roots are located on a left or right of a s plane. Two roots are located on a right half of a s plane. So the system is unstable system. Is it clear? Yeah, fine. So the number of sign changes in the elements of the first column of the row array corresponding to the number of roots of the carry equation in the right half of a s plane. Is it clear? So particularly what is the main conclusion here we can take, if the order of sign changes of the first column elements is, so if we here we are having this order, for example, having that one positive is there, negative, positive, and positive here, this is the order of sign changes what we are having. So How come we can consider the number of sign changes here? Positive to negative, one sign change, and again negative to positive, another sign change. So two sign changes are there. So if two sign changes are there, means two roots are located on a right half of a S plane. Is it clear? I hope that it is clear for all of you. Fine. Now let's we go move to the next level discussion. So first of all, we will know how come we are getting this b0, b1, b2, b3 and b4. How we are going to calculate this elements, this third row elements. This first row and second row is readily available for us with the help of this char equation, but this third row we supposed to calculate. So how we are going to calculate this third row, now we will going to discuss. So now see here, this is the char equation. This the coefficients of the polynomial are arranged in two rows. Is it clear? This is the char equation what we are having. So the coefficients of this particular polynomial what we are having is easily arranged in two rows as shown. Is it clear? Now when n is even means the row is formed by coefficients of even order terms. Is it clear? The first row will be formed by coefficients of even order terms, uh, and if s power n minus rho is formed by coefficients of odd terms. Is it clear? Now when n is odd, first of all, when n is odd, here we are having, when n is odd, here we are having, when n is odd, s power n row, this s power n row is formed by coefficients of odd number, and s power n minus 1 row is formed by coefficients of even order terms. Is it clear? I hope that it is got a you got a clear idea about this. So the other rows of the row array up to an s power 0 row can be formed by the with this following procedure. So each row of the row array is constructed by using the elements of the previous two rows. So this is the two rows what we are having. With the help of these two rows, the next rows will be created. Is it clear? Mal undani. One second, please wait for a while. So, we are considering the two consecutive rows of the row array as shown below. This is the one row. This is the two. This is the rows what we are having. Now, next row, how we are going to construct the next row? This is the next row which we are supposed to construct. This Z0, Z1, Z2, Z3 are the elements of the third row. So, how come we are going to construct? So, simply I can say here, how come we are going to construct is, so this is a formula what we are having: y naught into y x1, y naught into x1 minus y1 into x naught by y naught. Is it clear? How the z naught z naught is constructed by what? Y naught into x1. See here, be careful. Y naught into x1 minus y1 into x naught by y naught. That is for z1. Now for z naught. And how we are going to construct, we are going to calculate for z1. For finding out z1, this one we are not considering. Again, this first one and this one, y naught into x2. See here, y naught into x2 minus y3 into, see, y2 into x naught, y2 into x naught by y naught. Is it clear? This y naught will be common for all. Is it clear? And similarly for calculating z3, z3, these two rows I'm not considering. The first this first column I'm considering, and this 1 2 3 fourth column I'm considering. So y naught into x3 is for finding out this z2. Y naught into x3 minus y3 into x naught, y3 into x naught by y naught. Similarly, it will be keep on, it will be go on. Is it clear? For different elements, in such a way we are going to construct. So the elements z1, z2, z3 are computed for all possible computations as shown here. Is it clear? Now here, while we constructing, I hope that it is clear for all how we are going to how we are going to calculate the elements b0, b1, b0, b naught, b1, b2, b3. So for finding out b naught, what we supposed b naught element, what we supposed to do here, see here, b naught we supposed to find out. So a1 into a2 minus a3 into a naught by a1. For finding out b1, this we are not considering, only this one and this one. For b1, a1 into a4 minus a5 into a naught by a1, like that. So now, while constructing the roth array, one may come across three cases. So while we are constructing the roth array, we come across the three cases. The first case what we are having is a normal roth array. A normal roth array. So there won't be non-zero elements in the first column of the roth array. That is a normal roth array. Simply we are just constructing. We are not arising any difficulty. So based on the sign changes, we saying that the system is stable system or unstable system. Now next case 2, what we are having, suddenly while we are constructing the roth array, a row of all zeros we coming across a row of all zeros. So that is the case 1. Case 2 and case 3 is sometimes what happens in the case 3, one more thing what we are having, the first element of the row is 0, but other elements are not 0. So the first element of a row is 0, but other some elements are not 0. So these are the three cases what we are having. So what happens if this particular cases arises, so that we are going to discuss now. So when the case 1, normal roth array, so in this case what happens, there won't be any difficulty in forming the roth array. So normal roth array means we not have, that is the case 1. So there is no any difficulty in forming the roth array. The roth array can be constructed as explained just now, what I have explained. Based on the sign changes are noted to be find the number of roots lying on the right of a S-plane, and the stability of the system can be easily estimated. So in this case what happens, no sign change in the first column of the roth array, that all the roots are lying on a left of a S-plane and the system is stable. If there is a sign change in the first column of the roth array, then the system is unstable and the number of roots lying on the right of a S-plane is equal to number of sign changes. Is it clear? So and the remaining roots will be lying on the left of a S-plane. That is in the case of case 1. Now when we talk about the case 2, I already said that all the a row of all zeros in a row of all zeros. So what happens, a row of all zeros means, so a row of all zero indicates the existence of a even polynomial. Is that clear? As a factor of the given carry equation. So in the even polynomial, the exponents of s are even integers or 0 only. So the even polynomial factor is also called the auxiliary polynomial. We calling it as the auxiliary polynomial. So the coefficients of the auxiliary polynomial will always be the elements of the row directly above the above the zeros in the array. Just look at this once. Up to, from here just look at how we are, just look this how we are going to construct this for a while. I will just continue with the next topic. Just everyone please go through this from here to here. It is clear, right? I'm moving to the next discussion. See, a case 2 here we're having. A case 2, what happens? A row of all zeros arises. So, this what happens here when a row with all zeros? First of all, what we're supposed to do, the roots of the even polynomial occur in pairs that are equal in magnitude and opposite in sign. So, we will take one example for this one. So first of all, here when a row with all zeros arises means what we supposed to do is, first of all, we supposed to determine the auxiliary polynomial, that is a of s. So after determining the auxiliary polynomial, we supposed to differentiate the auxiliary polynomial with respect to s to get d a of s by ds. So the row of all zeros is replaced with the coefficients of this dA of s by ds. Is it clear? Now continue the construction of the array in the usual manner as in the case of case 1, and the array is interpreted. What happens here? Interpreted as follows: if there is again the same thing, if there is a sign change, so based on the sign change we say that the system is unstable system. If there is no any sign changes, we say that the system is stable system. So here for this we'll have one example problem. So now here what we are having is this is a char equation equation we're having. So here we supposed to comment on the location of roots of the char equation. So this is the char equation what we are having. So this char equation which we are having here, it is a fourth order equation, right? It is a fourth order equation. So it having four roots. So since this highest power of the s is even number, right? S is even number. The highest power of s what we are having is even number. So the first row of the row array using this coefficients of even powers of s, and form the second row using the uh, coefficients of odd powers of s. Is it clear? So first of all, s power 4. Here we supposed to consider the coefficients of s power 4. Here I am taking, so the coefficients of even powers I supposed to consider. So s power 4 coefficient, here we are having a 1, and next s power 3 I am not considering, and I am just taking this power s power 2, that is 8, 18, and next what we are having is 5. Is it clear? Next, this is the odd coefficients. So the second row is formed by the odd coefficient. So s cube means 8, 16, and there is no any elements here we're having, just I'm not taking anything. So these are the two rows we will get from the char equation what we're having. And next, the third row I supposed to consider here. So now for simplification I can just see here, this can be simplified. I can simplify this. S cube is the s cube row is there na, it can be divisible here, the elements here are divisible. So I can, instead of 8 and 16, for the simpler calculations what I'm doing is I'm just considering this as a 1 and 2. Is it clear? 1 and 2 I'm just considering here. So I need to consider this s power 2 row. So how come I can consider here 1 into 18 minus 2 into 1 by 1. Is it clear? That is the first element here we are having, that is 16. And next for this one, 1 into 5 minus 0, 1 into 5 minus 0 by 1, so it will be 5. So 16 and 5 is this row, s power 2. And for s power 1, how come we will get here 16 into 2 minus 5 into 1, 16 into 2 minus 5 into 1 by 16. So again, this is what we are having here, s power 1. What we are having, only one element is, that is 1.7, and the next element we won't have. Why? Because there won't be any element over here. Similarly, for having s power 0 row, what how many elements here we are having? So 1.7 into 5 minus 0 by 1.7. Is it clear? It will be 5. So in such a way we are going to construct the row array. So based on now here on examining the location on examining the elements of the first column of the row array, it is observed that all the elements are positive and there is no any sign change here. So hence all the roots are lying on the left half of s plane, and the system is nothing but what? The system is stable system. Is it clear? So this is the example 1, based on this case 1. Now when we talk about the case 2, see, I already said that while constructing a row array, what happens, a row is completely zero. A row, what we are having is we are having a row with completely all the elements are zero. So how come we are going to construct the row array? See here, I'm going to take the another example. Now here in this example what we are having is construct the row array and determine the stability of the system whose char equation is given. So this is the char equation which is given, and also determine the number of roots lying on right half of a s-plane, left half of a s-plane, and on imaginary axis. So this is the char equation what we are having. So first of all, two roots we will get directly from the char equation. So here the here the highest power of s is now nothing but what, it is the even number. So the first row will be coefficients of all even numbers, right? So s power 6 here we are having, what we have what row will be formed by 1, 8, 20 and 16, and second row will be odd number coefficients, s power 5, that is 2, 12, 16. So it can be simplified here. So for simpler calculations, we can replace this with 2, 6 and 8, sorry 1, 6 and 8. Is it clear? So s power 4 we supposed to construct, and when we talk about this one, s power 3 row will be all zeros. So what happens if s power 3 is all zeros, means what happens, there will be a existence of this auxiliary equation, that is a equals to, that is nothing but what we supposed to consider this one. If this is 0 means we supposed to take this above row. Above row is nothing but how we going to write the auxiliary equation, a equals to s power 4 plus 6 plus 6x square, s power 4 plus 6x square plus 8. Is it clear? This is the auxiliary equation what we are having. Now I'm going to find out the differentiation of this auxiliary equation. Is it clear? With respect to s, so dA by ds, that is nothing but what, 4x cube plus 12s. So finally the coefficient of this dA by ds will be nothing but what, which is used to form this x cube this row. What are the coefficients here we are having? 4 and 12 are nothing but we can take as 1 and 3. Is it clear? For simpler calculation, so just I'm replacing these zeros with 1 and 3 here. Again, after replacing this, again I'm with the normal procedure I'm going to construct the row array. So finally, how many, up to where I supposed to construct, up to s power 0 I supposed to construct the row array. Is it clear? So finally, after constructing this one, again I need to check the column 1, elements of the column 1. If any negative change, if any negative sign is there, means we say that the system, some of the poles are located on a right half of a s plane. If there is no any negative sign, we say that the system is stable system. If any negative sign we found, means we say that the system is unstable system. Now one more thing here we supposed to do, we supposed to take into consideration the row with all zero indicate the possibility of roots on the imaginary axis. A row with all zeros indicates that the possibility of roots on the imaginary axis. So what we can say, if the roots are on the imaginary axis, we said that the system is limitedly or marginally stable system. Now what are the roots which is located on the imaginary axis, then we are supposed to find out. Now I'm just considering this auxiliary equation, that is nothing but what, s power 4 plus 6s square plus 8. Now just I'm doing the simple mathematical analysis. I'm finding out the roots of that auxiliary polynomial. So these are the roots what we're having for this auxiliary polynomial. So these are the roots what we have. So the roots of the auxiliary polynomials are also roots of the char equation. So hence 4 roots are lying on imaginary axis, and the remaining 2 roots are lying on left of the s plane. Is it clear? Total 6 roots are there. Sixth order system. 6 roots are there. Out of 6 roots, here 4 roots. These are the 4 roots what we are having are lying on a imaginary axis. So if 4 roots are lying on an imaginary axis, how many roots left? 2 roots. The 2 roots are lying on a left of a imaginary axis. There is no roots lying on a right of. Why? Because here we are not having any negative So finally, what is the conclusion we can give here? So finally, we can say that the system is limitedly stable or marginally stable system. Is it clear? Why? Because some of the routes are lying on an imaginary axis. So finally, our conclusion is four routes are lying on imaginary axis, and remaining two routes are lying on a left of a face plane. Just once, everyone, please go through this example once. It is clear for all. Any doubts in this row theory? Please inform me. I will again discuss once one more time. I will for now. I will stop for the class for now. If any doubts regarding this Routh Harwich criterion, please ask me. I will discuss one more time. This is very important. This Routh Harwich criterion. So please, if any doubts, you can ask me. For now, for today, I will stop here. Just for today, we just go through the things what we have discussed so far regarding this stability, concept of stability, and this Routh Harwich criterion. So case 3 we'll discuss in the next class. For now, I'll stop here. Any doubts, please ask me. Any doubts, anyone having any doubts, you can ask me. Anyone having any doubts, you can ask me regarding the construction of Roth array, regarding the cases. Three cases we have discussed. So regarding the cases, so what are the three cases? First case is normal Roth array. Second case is a row with all zeros. Third case is a row with first element is 0. A row with first element is 0. So when we talk about the third case, if a row with the first element is 0, then what happens to the next row? Next row means what happens? Next row, all the elements will be infinity. Is it clear? When we calculate the next row, what we will get, all the elements of the next row will be infinity. So in that case, what we are supposed to do? How we going to construct the Routh array? So that is the thing that we are going to discuss in the next class. So up to these two cases what we have discussed so far, if you have any doubts, you can please ask me. If everything is clear, means we'll stop here and we'll start in the next class. Or else, yeah, we'll have time. We'll having time. We'll discuss this case 3 also. So one more example problem we'll discuss. Uh, for the case 3, see here. What happened here? This is the carry equation what we're having. For the carry equation, we're supposed to comment the location of roots, or location of the roots of the carry equation. So what are the location of roots of this particular carry equations we're supposed to find observe now. So again, I'm going to construct the Routh array. So first two elements of the Routh array readily available from this carry equation. So here here what we are having, the highest power of s in this carry equation is odd. So the first row is with the odd number coefficients, odd number elements, coefficients of the odd number elements, right? And second row is even number, even number elements coefficients. Now when we construct this third row, when we constructing the third row, so what happens means s power 3, in s power 3 row, the first column, first element of the row is 0 we will be getting. Is it clear? So what I'm doing is, when I'm getting the 0, the first element of the row, when I'm getting 0, I'm just replacing that first element with 0 with epsilon. 0 I'm replacing with epsilon. Is it clear? I'm just replacing the 0 with epsilon, and I'm just constructing the array by replacing that 0 with the epsilon, and I'm simply by using the normal procedure I'm constructing the row. I'm constructing the row array. So after constructing of row array, what I'm doing is this epsilon again I'm putting to 0. Again I'm letting this epsilon to 0. Is it clear? After the construction of row array, what I'm got, again I'm replacing this epsilon with 0. So this is the thing what we're having. So on observing the elements of the first column of the row array, what we have found here, we have found that there are two sign changes. Is it clear? This is the minus 2 here we are having. So positive to minus 1 sign change, and minus 2 positive another sign change. So two sign changes. So hence two roots are lying on a right half of a S plane. So the system is stable system, and the the remaining three roots are lying on a left half of a S plane. Is it clear? System is unstable system. Why? Because here we are having a negative sign we are having. So with this two sign changes, so what we say is that we say that the system is unstable system. Is it clear? I hope that the three cases clear for you, and in the next class we'll discuss some other cases. For now I will stop here. Okay, some other example problems we'll discuss. Only three cases are there, not more. Only three cases. First case is a normal row array. We are not arising any difficulty in the first case. In the second case, a row with all zeros. When a row with all zeros, what indicates? It indicates the existence of auxiliary polynomial. So when the existence of auxiliary polynomial takes place, means there are the roots on the imaginary axis. Now third case is a row with the first element 0. When a row with the first element is 0, means what happens? The next row will be uh, infinity when we calculate directly. So for that, what we are doing, we are replacing that 0 with epsilon, and we are constructing the array. After the completion of the construction of array, a row array, what we are doing, again we are replacing that epsilon with a 0. And again after replacing the epsilon with 0, similarly what we doing, we are going for to we will finding the any sign changes are there. If any sign changes are there, means based on the sign changes, we say that how many number of poles are located on a right of a S plane, and with that system is unstable. If there is no any sign change, we say that the system is stable system. Is it clear? Yeah, for now I will stop here. Any doubts? Yeah, thank you all. I will stop here. In the next class we'll discuss about the some more examples based on this particular row hierarchy criterion topic. Thank you all.